real-time data pipeline in Java. Within Java, how you can build a real-time data pipeline, I want to explain that now. In order to build a pipeline, you need the architecture and requirement document. So if you see the high level the architecture is, you need to ingest the real-time event, right? You need the data. What is that you want to read? Read API data, logs data, transaction related data, and database related data, or events also you can create. So once you ingest that data, you have to stream the data via message broker. Okay? You need to pump that data through message broker. That is the second step. Third step is you can process the data in real time, right? You can process it. So once you receive the data from the queue or topic, which was published by the message broker, you can actually process the data in real time, right? And after that, you can store the data in any NoSQL database for analytical purpose. You can actually do some apply analytics for analysis purpose. Optionally trigger alert. You can also trigger the alert. Okay. You can also trigger the alert for the particular pipeline. You see the simple diagram here using arrow. The producer cell produce the data into Kafka topic, and the stream processor is able to process the data and store the data into cache. So you can also store the data into cache and generate the data. You can see producer sends the data, SAD architect, Kafka real-time messaging to consumer processes the data. Database can be any NoSQL database, you can use MongoDB, Cassandra, PostgreSQL, any other NoSQL database. But you can also use relational database, right? So technology stack Java 17 plus. You can use version more than Java 17 because it is actually supporting the Kafka related dependencies well, and can actually build pipeline very well. Simple lines of code. Spring Boot, Apache Kafka, you need to install Apache Kafka if you are running environment or some server. You can actually make and provide the Apache Kafka and the Spring Boot, PostgreSQL storage. Real-time transaction monitoring, user generally makes any transaction. So whenever the user makes any transaction, banking or any banking or e-commerce application, as soon as they place an order, they have to generate a notification, or they need to update the data into some other analytical event. So you need to pump the data, you need to establish a data pipeline. How do we do that? So for example, user is going to make a transaction, right, and then event goes to Kafka. So based on the event, okay, Kafka will what it will do, it will produce the data into produce that particular data to Kafka topic, and consumer listens to that particular event, and as soon as the data is published, it will be processed by the consumer. You can apply some use case, and you can write some logic to process that, and you get the record based on the rules, and you can also store the data into NoSQL database, and you can also secure the alert. So implementation part you see, first thing is you need to set up if you have a Docker, you can put it on the image file based on the document. You need to create a POJO. What is the event that you are going to publish? The event model, transaction event model, IP. Is having published like ID, user ID, amount, location. Okay. You need to write a producer con class because we need to specify the variable cost size and what is the local code. Okay. And serializer, like the key serializer, value serializer, we need to specify that. So key plus the value is JSON standard, JSON serializer dot cost like that. And you can create a field for the Kafka template. This is the one we use to publish the data. And you see the service class, what we are doing is we are actually authorizing Kafka template. Kafka template of type string comma execution parameter string comma transact. So we declare the serializer. This serializer is a string serializer dot class, value serializer JSON serializer. So it is of transaction model, right? It is a Mojo. So it is some it is of JSON type, value serializer, and we are sending this data. It will be passed as a JSON. Okay, Kafka template dot send. You can see here. Topic name you have to provide the topic, and for which topic you are going to publish the data. You can have to specify. Okay. So you are going to publish this particular the data can be transaction data, or it can be log data, API data. Okay, it can be anything. So if you have some transaction is occur, you are going to publish the data into Kafka topic, and you can see this is the REST control. How do we invoke it? So you want to invoke post mapping. There is a method send a transaction. So transaction producer. Okay, transaction producer. This is a service, right? We want to produce a transaction. Okay, we are actually firing a event. We are using API call here because we will actually invoke this API. So how do we the publishing happen? It can be happen through API or maybe some business logic, or it can happen through some some business layer, wherever some transaction occur. Immediately have to publish the business. For example, we are dispensing an API. This API can be called by any other API. For simplicity, we are actually using API. Post mapping, request mapping, class transaction. When you invoke it, it will actually invoke the producer, transaction producer service. Inside which we actually authorize the transaction. We are actually publishing the transaction. And for consumer, also Kafka consumer, we need to have we need to specify these details like account details and the code wherever is Kafka server is running, and also the group ID. We need to have the group ID. Okay, for a particular Kafka topic, and specify the key serializer, deserializer. See what is the deserializer? First is string deserializer class, JSON deserializer class. Okay. Other side we are actually deserializing. Producer serializing the data and pump it into topic, right? And now we are deserializing. See here. We are deserializing, and you need to create a bean for what is this concurrent Kafka listener container type. Kafka listener container type. Okay. So we handle the concurrent Kafka. This is the concurrent Kafka listener, and this is concurrent listening as well. here is the main thing, the consumer for transaction service. You need to specify, you need to mark the method using accurate cost calculation. That way it will reduce the circular cost. You need to provide the copy for which you have to visit to the event. And the group ID, under which group ID this topic is there. You need to specify. You can have multiple group IDs, right? If you want to get multiple topics, group ID will be helpful for you. And you can see here we are actually consuming, it will consume the data automatically, and you can apply some processing logic here to this transformation logic and processing logic. You can apply it here in the consumer. Okay, and then you can actually save that info into NoSQL database if you want to store that. The transaction report you can see here. Simply you can create a transaction entity, a database layer, you can expand the API repository, and then you can store it. So these are the steps, high level steps. 7 steps are there. Client API, we will invoke the REST API, producer can say you get the task control, data in target, consumer use that we can see, and you can apply transformation processing logic here, and execute, and you can insert that data into logical BPF, MongoDB, whatever it is. And after that, you can alert the triggered alert. You can also provide the notification details if you want. So if you want to make it advanced, there are enterprise level, you can see we add this the standard exactly one processing. Okay, retry and deadline queue. So generally we will use if some message is missed from the customer, so retry and deadline queue will be helpful for you. Failed messages go to the DLC copy, and from there you can process it again. Schema validation, Avro for schema tuning. You can define the schema using Avro and schema request. Real-time dashboard. You can use WebSocket and React. You can also scale multiple consumer methods. You can actually scale it. So this is all about real-time data processing. I want to explain the batch level data pipeline as well, high level. I hope you are aware of the batch level data processing. The key part is only real time, which we already discussed. The batch level is very simple. Real time means as soon as some transaction occurring in the business layer, immediately we will publish that data into database, and from there we will read it instantly and process that. But batch layer is different, right? We will schedule, we will actually create some cron jobs or batch processes, and they will get executed periodically based on the time, based on the schedule time, right? The batch jobs will be scheduled based on some scheduled time slot. So use cases, you can actually take a CSV file, and we want to read that CSV file. The batch job will read that CSV file, and it will apply the transformation logic and processor, and then it will write that to database. So 3 steps you can see. First thing is you need to read it. After that, apply a transformation logic and store the output into some other database. We are using the Maven project, right? Build tool. We have this 3 different things are required. You can see that there. Input model is here. Transaction code here. We are reading the CSV file. Simply apply IO operation, Java, IO package, file system details, and we are going to read that a flat file item reader. We created an object for that of transaction type, and then we are actually we need to tokenize it. We need to read the data, right? What we have to read, we have to read what are the tokens that we are reading, what are the columns that are the CSV file, ID, user ID, amount, transaction. These are the inputs. So we need to code like this: reader dot set line mapper of new default line mapper and set line mapper, set line tokenizer. So So based on these these header values, it will read the particular data. So you are going to have a reader from which you can actually read the data. So processor, what is that processor? You are going to apply some transformation logic. Let's say you have a this transaction for each row. This transform logic is the frequency. Whenever the transaction amount is greater than 10,000, then I just print it as a high value transaction. So you can also apply some logic for a particular column. You can modify it if you want. But this is a simple short detection tool. So writer, there is a load step. In the load step, we are going to create a GDBC batch item writer created object, and we can actually insert the data in the table. Okay, we need to take a data source. So it can be the data source of any analytical DB, and we can actually store the data. So the job configuration is the main thing here, but string batch, because we are using a string batch, you can see here. First thing is you need to create a bean for job, and you need to create a step method, because to which your job will be executed and can specified in this particular method. Okay, you can see here step builder and the job repository transaction func 10 comma transaction manager. You have actually need to specify what is your reader, what is your transformation logic, what is your writer, and also the basic. There is a concept for 10 comma transaction manager. I think it will do some I think parallel processing when you apply this. And you can actually, I'll explain this later, but now this is the high level thing. We were doing a step here. Okay, where you have to provide these three steps. First step is reader screening step. Next step is the processor transformation logic. Third step is load writer screening. Okay, so this is how to create a bean for step and the job. So now the final thing is scheduling. You are going to create a job launcher, right? So you need to create a cron job kind of step here. Schedule the cron equal to 0 space 0 star for every hour. For every hour, the job will get executed. And you need to specify this using a string schedule. Okay, this is the method that invokes the main job. You see, the chunk of 10 means the reader reads the CSV chunk of 10 rows. You can see here. First, if you read 10 rows, transform the right. Repeat until 5 times. So it will read the 10 rows at a time. That is, instead the chunk of 10, it will read 10 rows at a time. Just until the repeat that value. So how you are launching? You are actually launching it here. Launch of site here. Okay. You can apply some fault tolerant scenario, and retry limit the retry logic. Sometimes in this fail you can apply retry in 3 times after that exception. Some partition parallel processing. Split large files into chunks processing parallel. These concepts are there. You can make batch enterprise level cron job restartability, job phase residence for the last process. So these things you need to take care when you want to make it a real-time pipeline, offline pipeline. So I explained you both real-time and offline batch kind of pipeline job. So that's why we can build both pipelines, and I can actually use them for